So this first note card moves to the right. So you're going to find this note card and write that equation on the back. So pause the video and do it now. Then you're going to find this graph. This is moving to the left. You're going to write this equation on the back of that card. Now you're going to find the next equation, which is the up. Find the up. Inside the function is what you would think should happen. +1 means up 1, right? Because we got to keep all these different rules in our head. Whatever the rule is for absolute value is the same rule for quadratics or square root function or cubic function. Okay, so that was our up. And now you're going to find the down. So here's the down. So find the one that moves down. Then we're going to do after this the stretch and the shrink if you want to find those. But for the down one, I'm going to write absolute value of x with a -2 on the outside to shift it down by 2. Okay. So my next one after this, can I move this one? Yeah? Next one is going to be the stretch. I'm stretching it taller than it started as. I'll put these up here for later in case you got behind. This is a stretch. Where does the stretch go? It goes in front of the function. How much is it being stretched? Times 3. So y equals 3 times the absolute value of x. Goes in front of the function. Times 3 means the slope is now 3. So the next one I'm going to do after this is the shrink. It's less tall. So if you want to find the one that has the, oh, actually, do we have a shrink one? Write an equation. This one's upside down. I don't know. Because one of them just says find, oh, this one I found it. Okay, can I move that one? We're done with stretch. Here we go, write an equation. This one is the same, just so you know. One of them says write an equation and one of them says find the domain. So this is the one that says write an equation. So this was our stretch. Okay, this time what is the slope of that line? What's the slope? So y equals 1/2 absolute value of x. So you can write that one and then find the flip upside down problem. There's an absolute value that's been flipped upside down. A lot of stuff. Cardboard, glue sticks, popsicle sticks, clothespins, paper. Yeah, I have popsicle sticks. All right, I'm doing the one that gets flipped upside down right here. And then I have one more equation, and then there's 2 that are like domain and range, I think, of those. Okay. This one is flipped upside down. So where do I put a negative sign? In front of the function, right? Y equals negative absolute value of x. It goes in front of the function if it flips it upside down. I think there's one more where it says, can you write the equation? And this has like a double shift. Can I switch it? You good on that one? Okay, so find this one. Write the equation here. It's been shifted like left or right, and it's been shifted up or down. It's a double shift. How would I write the equation for this function? Let's see, it's going to the what? The right 1, 2, 3 units. So inside the absolute value, x minus 3 to go to the right. And it's been going down 1, 2, 3, 4 units. So a -4 outside of the absolute value or parenthesis. I think of it as parenthesis because this is inside with x. It's the opposite of what you think. This is outside of the function. All right. The next two I'm going to find the domain and range, and they're both absolute value. X minus 3 minus 4. Is there another equation one? Write the domain. That one just says find the domain. Okay. I need to check off the 7 anyway, so can you just put that up for a minute? Okay, so there's that one. All right, what is the domain for any absolute value function? All real numbers. Those arms are stretching side to side, so you can write all real numbers. You can write it like that. You could write boldface, capital R. You could write negative infinity, up to positive infinity. Any one of those means all real numbers. Because the x values are going forever from side to side. So I'm going to say x can go forever side to side, right? Because domain is x. So domain, maybe you want to write on the back the domain is x. What are the allowable x values of the function? But range range is not going to be all real numbers for this one. Or for the next one anyway. Can I switch it? You don't have to write all of those. I mean, any of those is kind of an acceptable answer. All right, the next one is this one. Find the range of the given function, and it's another absolute value. This time, my y values can't go forever. What's the lowest I can go? I start at 4 and I go up forever. I can't go below 4. So I would write that y has to be greater than or equal to 4. All the y values, right, are above 4. So the shark's mouth faces the y value. Okay, so now you can find all of the graphs that say identify the parent function. And I'll kind of go in order of how we learned them, but the first one we learned this year was that one. What's the name of this function? It was linear, but I don't want you to forget it. So linear. So it says identify the parent function, because some of those say find the domain or range or y-intercept, x-intercept. This one says identify the parent function linear. Good on that? Next one is going to be this one, identify the parent function, and what is that name? The quadratic. Identify the parent function. This is good. My walking gives you time to write it. Okay, identify the parent function. This one's going to be quadratic. The next one in order is going to be the squiggle through the axis. We got quadratic. So the squiggle through the axis, what is the name of that function? We did linear, quadratic, so the next level up is cubic. Right, quadratic is x squared, cubic is x cubed. So this is a cubic function. And you could also write this on the back. Like a cubic function may be a little bit more exaggerated. So that's also what a cubic function might look like. And it looks like I have like 3 more of those. So this one is, what's the name of this one? Not a cube root. Cube root actually goes forever side to side. This is just a square root function. It's half of a parabola. And I'm not going to have you graph this by hand, but it might be nice to know from a word bank, you know, which each of these are. So this is a square root, right? This symbol, square root. And then the last two of this type of note card is the exponential increasing and exponential decreasing. So you can find those two. That would be the next one. Is this exponential increasing or decreasing? Yep, because when you read it from left to right, it's going up. So you read a graph from left to right. So this one is called exponential increasing. The other one is called exponential decreasing, if you want to do that one at the same time. I'll put it up in just a second. Exponential increasing, exponential decreasing. So this is exponential decreasing. You can put it on the back. Exponential decreasing. There you go. Let's see. How about the next four that we do are the four that have just a line on it? One says like y-intercept, x-intercept, domain range. I'll start with y-intercept. Am I good with exponential decreasing? So do y-intercept, because some of us are still confusing. Do I write it 0, comma the number, or the number, comma 0? What is the y-intercept on this graph? It's at 1, 2, 3. So how do I write that? I don't just write 3. So 0, comma 3. The y-intercept is 0, comma 3. The next one you can find is the x-intercept. Are we good with the y-intercept? I don't know. X-intercept, what's the x-intercept? Yeah, it does look like 4.5, doesn't it? See where it's crossing right there on the x-axis? And so how do I write an x-intercept? I would write 4.5, comma 0. Did everyone see where that one is? 4.5, comma 0 is the x-intercept. That one a lot of you need practice on. Just have it write it in the correct order. All right, and then how about domain and range of a line? Domain and range of a line. What's the domain? X can do what? Can it go forever in both directions? Yep, so all real numbers for the domain, and also it can go up and down forever. So it's also all real numbers for the range. So both on the domain and the range card, you can write the boldface capital R. You could write all real numbers. I like to do boldface capital R. It's just two straight lines with the curve of the R. So both domain and range card, you can put all real numbers. The next two cards I have are the vertex or standard form ones. So after I hang these up, we'll do the vertex. Can I move that? Vertex or standard form for that one. What would you say? That is vertex form. It has parentheses. It does not have an ABC value. It has an A value here, but that's H and K. Your left and right and your up or down. So that is vertex form, which makes the other one standard form. But I think some students are trying to like multiply this out in order to graph it. Don't do that. Just say, I'm going right 4, up 6, and I'm graphing it right there. So vertex form, you do not want to multiply out. So the other one is standard form, because you've got your A, B, C value. Maybe you want to throw on there negative B over 2A. Remind yourself. If you don't understand what A, B, and C is, I would write AX squared plus BX plus C, if you need to know that. Up to you how much you put on your note card. Let's see, we're on the last two, right? The increasing or decreasing one. Can I move standard form? Let's do the 0 to 1 guy first. Is it increasing or decreasing? What would you say? Let's see, from 0 to 1, it's actually decreasing because it's talking about this little section of the graph right there, right? From 0 to 1. As I read it from left to right, it is decreasing. And then the other one must be probably an increasing one, right? Let's say from -4 to -2, it's also decreasing, isn't it? No, I'm talking about the graph though. So the section of graph that I'm talking about from -4 to -2, it's still coming down, right? So as I read the graph from left to right, even though that arrow looks like it's pointing up, I read the graph from left to right, the graph is coming down. So the arrow tells you it goes forever, but increasing or decreasing is reading it from left to right. If I was over here, it's increasing here from 3 to 4, right? So that was actually kind of a trick question, but decreasing. All right, so you've got your 24 cards. Is what? Which one are you asking about? The -4 to -2? So they're asking you, are the y values increasing or decreasing when x goes from -4 to -2? So you're looking for this stretch of the graph. The y values are coming down. Same thing right here. The y values are coming down. If I ask you from like 1 to 3, now the y values are going up. So x is always increasing. So x is always going from left to right. So x is always getting bigger no matter what I ask you. So it's the y values. Maybe on your note card, you want to ask the y values. Are they increasing or decreasing? All right, who needs a paper clip or just shove them in your you want to write that one in Jackson. And then you throw your scraps away. We're done with the note cards. We're going to do a couple problems from the review. There you go. And then we'll have some moving around time, working on some catapults. Yeah. You guys can throw away your scraps. This is a clip to keep them together. There's your scraps. You can throw it away. And I think we're going to do a clip. Did I skip anyone? Did you guys ever make paper clip chains? I'm kind of thinking I should give like 100 paper clips to my children and be like, make them chains. That would keep them entertained. Huh? I don't think I want my kids thinking about how to make lock